All right, so hopefully this is the last video from chapter 2. I'm trying to put two examples here together. So the third way that you can get a 3D problem given to you is this blue triangles case. I didn't create this. Dr. Hansen was the one that created the blue triangles. And why does he call it blue triangles? Because when you see it in the textbook, the triangles are blue. Now the one and you can see the formulas here. You can ration these formulas out with trig if you'd like, but here's just use the formulas I've given you. However, my definition that I'm going to use is the one that also Dr. Hansen uses, is that phi is going to be the swing angle from the x-axis, and theta z is going to be the angle from the z-axis. In both cases, those are the positive x, the positive z. So it's applied. So here's a problem. Wow, look at that, blue triangles. So there is blue triangles for the AC cable in that particular case. Interestingly enough, they use tensions here, T's instead of F's, as in the other one. So we've got one that's completely on the AB is completely on the x-axis. You'll notice that AD has the three angles given. So we know how to do that with the directional cosines, and then we got blue triangles for the AC. So here's how we take and we figure out C. So phi is, remember, the swing angle from the positive x-axis. Well, they're showing you the angle from the y-axis as 30 degrees. So there's another 90 to get back to x. So phi is 120. Theta z, they're showing you here again from the xy plane up is 60. So we're going to go back 90, so 90 minus 60 is 30 from the z-axis. So with those two values, we can plug those in, and we get the components for fx, fy, fz. We don't know that tc is the unknown in that case. This is the author's solution, which I guess I kind of mixed my own solution in there. So TB, of course, is all on the x-axis, so there's only an I component. TC, we have, I just showed you how I did TC. You can see how the author did it here, which is slightly different, but you saw how I just did it. And then TD, you have the three angles, so you multiply TD times the cosine of those three angles. Again, we call them theta x, theta y, theta z, and you'll get TD. So what do you end up with in this particular case? Oh, and the weight, of course, is coming straight down, so it's on the negative z-axis. So you've got, if you apply your equations of equilibrium, like you've got, end up with three equations and three unknowns. So you have the sum of the forces in the x equals 0. Actually, it's mostly chapter 3, not chapter 2. Some of the forces in the y equals 0, and some of the forces in the z direction equals 0. Got three equations, three unknowns. You can solve those with substitution. I like to do matrices because you can just plug those into your calculator. Either way that you do that, whether you use substitutions or you plug them in, those are the values you'll get for this rate. So that's a good problem because it shows you all three ways. Or two, yeah, it shows you two of the three. It tells you it's two of the three ways that you can get something given to you in a 3D problem. So this is a similar problem to that last one. Very similar problem, except there's no blue triangles in this case. Right, the weight is all on the z-axis. The AB is on the xy plane. This AC is on the negative x-axis, and then you have 3 points, or yeah, you got the 2 points to find the last third one there. So if you look at the way I did it, based on they gave you the 30 degrees. If you use the 60 degrees on the other side, you could have put sine and cosine. If you like to do sine and cosine the other way, that's up to you. You can see FC again is all in the negative x direction. The weight is all down. Right, for FD, I identified the 2 points, found my position vector, divided that by the magnitude, got my unit vector, and multiplied that by the force, which is, of course, an unknown in this particular case. Applied my equations of equilibrium, got my three equations, my three unknowns, and it looks like, right, the equation 3, FD, just falls right out of it. and then I plugged that into F2 and I solved for FB, and then I plugged that into number 1 and I was able to solve for FC in that case. So there you go. There's a couple of other, that's chapter 3 actually in this case, and then you can follow through the solutions from the author, and they probably did a very similar thing to what I did. Again, that was chapter 3. I thought it was chapter 2 at the start, but chapter 3.